Okay. So this stream of experience that comes in, this sequence of observations, actions, rewards, we call it the history. So the history is what the agent has seen so far. So each step it takes its action, sees an observation, sees a reward, all the way up to the current time step t. And the history, ht, is basically the sequence of everything it's seen so far. And that's, in some sense, this is all the observable variables. Like there might be other things hiding inside the environment, but the agent doesn't know about those. It can't observe those things. And so in some sense, they're irrelevant to the algorithms that we create. The algorithms that we create can only be concerned with what the agent can actually see. Remember, we're trying to build that brain. The algorithm sits in that brain. And so we should only concern ourselves with what the brain is actually exposed to. And so you can think of this as like the sensory motor stream of a robot or an embodied agent. But this also applies more generally. A game-playing agent or a trading agent. It has its own sensory motor stream of what the inputs are that it's seeing and the decisions that it's able to take. There's some well-defined interface between agent and environment, and we just get to control and see this stream of stuff that's coming into the agent from its environment. And what happens next actually depends on this history. So the agent, our algorithm, we get to build something which is essentially a mapping from this history to an action. So that's our goal, is to build a mapping. An algorithm is a mapping from one of these histories to picking the next action. So what happens next from the agent's point of view depends on the history. And what the environment does is the environment looks at what it's received. It looks at the history of what's happened in terms of the agent, and it also looks at the history, and it uses this history to decide what it's going to do next in terms of what observation it's going to emit at the next time step. So this history literally determines the nature of how things proceed. The history determines what happens next. But it's not very useful. The history isn't very useful because it's typically enormous. We want to have agents that have long lives and can deal with microsecond interactions, and each of these observations may be a video, and we don't want to have to go back to this history every time. And typically what we talk about instead is state. And so state is like a summary of the information that's used to determine what happens next. So in other words, if we can replace the history by some concise summary that captures all the information we need to determine what happens next, then we've got a much better chance to do some real things with our machine learning. And we're going to spend some time talking about state. I think it's a really crucial concept that's widely misunderstood, and I really want to carry this over really carefully. So formally, what is state? So every time step t, we can construct this state, which is a function of the history. So it's just any function of the history. That's the definition of state. So a valid definition of state would be to only look at the last observation, for example, and just ignore everything that's come before, or to look at the last 4 observations. That's actually what we did in Atari. Pretty simple. Okay. But there's many different definitions of state, and what I want to pick apart now is at least 3 different definitions of state to understand what they really mean and how they relate to each other.